Everyone, today let's go over another medium Leetcode question in the backtracking section. I'm kind of weak at backtracking and I was actually not able to solve this problem, so I ended up looking at the solution after getting time limit exceeded with my solution, which was kind of frustrating, so let's go over it. This one is called the number of beautiful subsets. So as usual, if you solve subsets 1, you want to generate all the subsets, but this time with the constraint that before appending any number to the subset, it's not going to be the difference between that number you're about to append and any number that's already in the array is not k in terms of absolute difference. So it's kind of confusing, but essentially we want to go through all the subsets first and then get this constraint. So by using backtracking, you can actually do this, or you can use a combinations. So for a in combinations, or for, let's say that for I in range 1, length of nums plus 1. Now for a in combinations, nums, length of I, let's print a. And let's call this flag. And we can say we want to iterate over every single item in A. So j range length A, for L in range j plus 1 length of A, or perhaps just this, and then we can say if j is not equal to L, if aj minus al in terms of absolute difference is equal to k, then flag equals to false, and we can break right there because it's already violating the condition. If flag is true here, then we can print a. So let's see. So 1, 2, 3, 4, and now we can just increment result if that's the case. So let's increment result, and let's just return this at the end. Okay. So this is almost O(n) to the power of 4, so it might not work. And as you can see, probably going to get output limit exceeded and time limit exceeded. So if we keep, so you can see it takes a long time. So a better way to do it is, instead of doing this, we can keep making the sublist bigger as long as the number we're about to add is not conflicting with the last one, because we already compared the ones before the last one, ensuring they fit this constraint before we added it. So let's define a backtracking function to do this. Kick it off, and let's call this 0 and this, because we want to get the index and the current list. And if I is bigger than or equal to length of nums, then we're out of bounds. We can say if the current list is not none, then let's call this self.result plus equal to 1, and we always return. And then if that's not the case, because we returned, so if I is 0, I is 1, I is 2. If I is bigger than or equal to 2, then we're out of bounds. Otherwise, you can backtrack and we can keep increasing I to add a new element. Excuse me, my throat is kind of weird, kind of scratchy today. Okay, so I plus 1 in current. Now we can ask the question if all of, let's say, C, for C in current. So for C in, if all absolute value of C minus K is, or if C minus nums of I, which is the number we're going to add, is not equal to K, for C in current, this is a list comprehension, so it's kind of shorthand. It's just saying for every single element already inside of the current list, if the absolute difference with the number we're about to add is not equal to K, then we can actually proceed and add it. So cur.append nums of I, and then do backtracking again. And then after we explore all the possibilities, the length exceeds nums or I gets out of bounds, then we can pop. Then at the end, we can just return self.result and see if it works. So hopefully this works. There you go. So it passes all test cases. Again, I did not come up with the solution by myself, but you know, you live and you learn, and hopefully this adds something else to my toolkit. So I just wanted to show you, and hopefully you found this helpful. So thank you for watching.